The roar of machinery echoed across the sprawling Ford factory in Michigan, a symphony of metal, gears, and human determination that few outside the walls could truly comprehend. It was 1942, and the world was engulfed in war, yet here, amidst the relentless clatter of presses and conveyors, a feat of industrial genius was unfolding that would leave not only the Allies in awe, but German intelligence utterly stunned. A single bomber, comprised of 1.5 million parts, rolled off the line every 63 minutes, a staggering testament to human ingenuity, organization, and relentless pursuit of perfection. Observers would later call it miraculous. Spies reported it as unbelievable, and within these walls, vision, sweat, and innovation combined to achieve what most thought impossible, turning raw steel, rivets, and engines into flying machines that would dominate the skies and redefine the pace of war. The story began with Henry Ford himself, a man whose name had become synonymous with innovation and efficiency. His factories, originally designed for automobiles, had been repurposed to meet the urgent demands of wartime production. Engineers, managers, and workers were mobilized into an unprecedented coordinated effort, integrating assembly line techniques with precision engineering to handle the staggering complexity of a heavy bomber. Each component, no matter how minute, was cataloged, tested, and synchronized in a production ballet that required timing down to the second. The assembly line was not merely a factory. It was a living organism, a machine whose parts were human minds and hands, orchestrated to perform a feat that even the most seasoned industrialists had thought unimaginable. Every stage of production was carefully engineered for efficiency. Subassemblies were pre-built in parallel, so that when they converged on the main line, installation could occur without delay. Riveters, welders, electricians, and mechanics worked in perfect harmony, moving with almost choreographed precision. Conveyor belts carried fuselages, wings, and engines past hundreds of workers, each performing specialized tasks that contributed to the final masterpiece. Timing was critical. Any pause, any misalignment, could cascade into delays, threatening the target of a completed bomber every hour. Yet through rigorous planning, continuous training, and strict adherence to procedures, the factory achieved a rhythm that seemed impossible, a feat that would leave spies across the Atlantic shaking their heads in disbelief. German intelligence had long underestimated the scale and capability of American industrial power, assuming that producing heavy bombers would take months per aircraft. Constrained by the limitations of manpower, materials, and technology, reports sent back to Berlin spoke of congestion, shortages, and inefficiency, yet the reality was something entirely different. Within Ford's walls, a carefully crafted system allowed multiple aircraft to progress simultaneously through different stages of construction. Engines were tested as soon as installed, wings were riveted in parallel, and electronic systems were calibrated in real time. Workers became masters of multitasking, understanding not just their individual roles, but how each action fit into the broader timeline, ensuring that each bomber could be completed on schedule without compromise to quality. The speed of production was matched by its meticulous attention to detail. Each rivet, bolt, and wire was inspected, each system double-checked, ensuring that every bomber was not only produced rapidly, but built to withstand the rigors of combat. Engineers devised innovative techniques to streamline processes, including modular assemblies, pre-tested components, and standardized parts that could be swapped quickly. This integration of speed, precision, and ingenuity created a machine so efficient that even the most skeptical observers had to accept that something extraordinary was happening. Pilots who later flew these bombers often remarked that each aircraft was nearly flawless, a testament to the precision and dedication embedded in every stage of construction. The factory's workforce, composed of men and women, many of whom had never seen a bomber before, were trained to execute their tasks with unwavering focus and discipline. Labor unions, management, and engineers collaborated to ensure that morale remained high, that every individual understood the importance of their role in the war effort, and that the pace of production could be maintained without sacrificing safety or quality. The environment was one of intense pressure, yet also one of pride. Workers knew that each completed bomber represented a direct contribution to the fight against tyranny, and that the speed and efficiency achieved within these walls was nothing short of revolutionary. As the first bomber rolled off the line in the early morning hours, engineers and workers watched with bated breath, knowing that this was more than a machine. It was a statement to the world. German spies had expected delay, inefficiency, and limitations imposed by complexity. Yet the reality they could not fathom was unfolding in real time, a 1.5 million part bomber emerging every 63 minutes, ready to change the course of the war. The next wave of aircraft would roll forward with the same precision, yet the spies would remain unable to predict or comprehend the scale of what had been achieved. And deep within the factory, the hum of machinery continued relentless, unstoppable, as the industrial heart of America pumped its lifeblood into the skies, proving that ingenuity, discipline, and audacity could make the impossible a reality. As the factory roared to life, the true complexity of producing a bomber every 63 minutes became increasingly apparent. Engineers meticulously mapped out every stage of assembly, ensuring that no single task slowed the process. Wings, fuselage sections, and landing gear moved along conveyors with almost mechanical precision, while workers performed highly specialized tasks with unmatched focus. The integration of human skill and machinery created a rhythm so precise that any deviation could be immediately corrected. This synchronization was essential, for each of the 1.5 million parts required careful placement, testing, and verification, from the smallest rivet securing a panel to the massive engines that would propel the bomber through enemy skies. Innovations in modular assembly were at the heart of this industrial marvel. Subassemblies were prepared in parallel across different sections of the plant, allowing multiple aircraft to progress simultaneously without delay. Each section operated as a self-contained unit, yet perfectly synchronized with the others. Engines were installed and tested before the fuselage even reached the main assembly line. Electronics and wiring were pre-fitted and calibrated, and landing gear systems were pre-checked to ensure immediate functionality. Workers were trained to understand not only their immediate task, but also how it influenced subsequent stages of production, creating an environment where the entire workforce functioned as a single, unified organism. The factory also leveraged cutting-edge logistics for materials management. Thousands of parts, from aluminum panels to complex avionics, had to be delivered precisely when needed. Any disruption in the flow of materials could halt the assembly line, wasting hours of effort and potentially delaying the output of the next bomber. To prevent this, Ford implemented a system where supplies were constantly monitored, replenished, and routed efficiently, with contingency plans for every possible disruption. Trucks, cranes, and conveyors worked in perfect harmony with human workers, ensuring that production continued uninterrupted day and night. The result was a system that operated almost like clockwork, producing one bomber after another with stunning regularity. Beyond mechanics and logistics, quality control was a cornerstone of the operation. Each aircraft underwent rigorous inspection at multiple stages of production. Rivets and bolts were checked for proper placement, wiring harnesses tested for continuity, and engines run through trial procedures before installation. Engineers designed redundant verification processes to ensure that no defect could escape notice. Pilots who later flew these bombers would note that each machine was remarkably reliable, a direct reflection of the meticulous attention to detail embedded in every phase of production. Speed never compromised quality. Instead, efficiency and excellence were inseparable. The human factor was equally critical. The workforce included men and women, many of whom were new to heavy industry, brought together by a common purpose: to support the war effort and produce aircraft that would dominate the skies. Training programs were intense and comprehensive, emphasizing both technical skill and coordination. Teams were drilled repeatedly, each member understanding not just their individual role, but also the timing and sequence required to maintain the 63-minute production cycle. The culture of accountability, pride, and precision ensured that every worker was invested in the success of the operation, understanding that even a single mistake could ripple through the assembly line. German intelligence, monitoring from afar, could scarcely comprehend what they were seeing. Reports from Spies described production estimates that were entirely at odds with reality. While analysts in Berlin predicted that each bomber would take weeks to construct, the truth emerging from Ford's Michigan plants was staggering. One aircraft completed every hour, a pace made possible by innovation, coordination, and relentless discipline. The Spies were left both baffled and alarmed, realizing that the scale and speed of production gave the Allies a decisive advantage in the skies, one that could not be matched by conventional industrial planning. By the end of the day, dozens of bombers had rolled off the line, each a testament to human ingenuity, precision, and endurance. Yet the Spies in Germany continued to underestimate the system. unable to reconcile the staggering numbers with their understanding of manufacturing limitations. The next bomber would appear in 63 minutes, the rhythm unbroken, the scale incomprehensible. Inside the factory, the hum of machinery, the clatter of rivets, and the synchronized movements of thousands of workers continued without pause, a relentless heartbeat driving the production of machines that would dominate the war. The world outside could scarcely imagine it, and German intelligence would soon be forced to acknowledge that the very rules of industrial warfare had been rewritten. The extraordinary pace of production was not achieved by machinery alone. It relied on a meticulous orchestration of people, processes, and planning. Supervisors monitored each stage, ensuring that workflow remained uninterrupted, while engineers analyzed performance data in real time, identifying bottlenecks and implementing rapid adjustments. Workers moved with purpose and precision, rivets flying, panels being aligned, and engines installed with a combination of skill and timing that approached the mechanical perfection of the assembly lines themselves. The factory was a living system, where every individual, every tool, and every movement contributed to a synchronized whole, and even a minor deviation could be corrected instantly through the integrated oversight network that spanned the plant. Sub-assemblies were prepared in parallel across multiple floors and wings of the factory, each meticulously timed to converge seamlessly at the main assembly line. Wings were rigged, fuselages pre-wired, engines pre-tested, all ready to be integrated with the precision of a Swiss watch. Teams practiced repetitive drills, not just to enhance speed but to cultivate muscle memory and coordination, ensuring that each movement was second nature. This preparation allowed the assembly line to move without interruption, achieving the seemingly impossible feat of completing a 1.5 million part bomber every 63 minutes. It was an industrial ballet where chaos appeared impossible, and yet the sheer scale of the operation might have overwhelmed lesser systems or less disciplined teams. German intelligence had assumed that logistical challenges, labor limitations, and the sheer complexity of the bomber's components would prevent any such rapid output. Their reports predicted weeks of work per aircraft, extended supply chains, and inevitable delays due to human error. Yet the spies could not fathom the ingenuity behind Ford's modular assembly and synchronized workflow. The engineers' innovations, combined with highly trained teams, allowed overlapping construction processes that defied conventional expectations. Engines were tested as soon as installed, avionics were integrated in parallel, and landing gear systems were calibrated without slowing the line. Each aircraft progressed as if guided by an invisible conductor, moving from one stage to the next with unparalleled efficiency. The factory also employed a unique method of error reduction and quality assurance. Each worker was responsible not only for completing their assigned task, but also for verifying the work of the previous stage. This system of mutual oversight created multiple layers of inspection, dramatically reducing errors and ensuring consistency across all aircraft. Specialized tools and jigs further minimized mistakes, allowing teams to maintain speed without sacrificing quality. The result was a bomber fleet that not only emerged rapidly, but was combat-ready, structurally sound, and capable of performing under the most demanding wartime conditions. Beyond production mechanics, the workforce itself became an engine of innovation. Teams suggested improvements, streamlined workflows, and implemented new techniques that increased both speed and reliability. Collaboration between engineers, supervisors, and assembly line workers fostered a culture of continuous improvement. Even minor adjustments, when multiplied across thousands of tasks and repeated dozens of times daily, created dramatic cumulative effects that increased throughput. The human mind and machine had become inseparable, working in tandem to produce an industrial output that stunned the world and confounded German spies. The scale of coordination extended to supply chains, where thousands of raw materials, aluminum sheets, engines, instruments, fasteners, and wiring had to arrive precisely when needed. Trucks, cranes, and conveyance systems were synchronized to prevent bottlenecks. Logistics officers monitored inventories, anticipating shortages and rerouting supplies proactively. The seamless integration of material handling and assembly ensured that production maintained its astonishing 63-minute cycle, day after day, even as wartime demands surged and pressure mounted. By the end of this continuous operation, dozens of bombers had been completed, each representing not just engineering prowess, but a carefully orchestrated triumph of human ingenuity. German spies, observing from afar, remained bewildered, unable to comprehend how one factory could sustain such speed, precision, and quality. Yet inside Ford's plant, the hum of machinery and the synchronized work of thousands continued unbroken, relentless and unstoppable, as though the very heartbeat of America itself was pumping steel, rivets, and engines into the skies. The next bomber would emerge in precisely 63 minutes, and the enemy would be forced to reckon with the staggering reality. The rules of war had been rewritten through sheer industrial genius, audacity, and vision. The staggering pace of production was matched by the extraordinary innovation embedded in every corner of the factory. Engineers devised methods to pre-assemble complex subsystems in parallel, ensuring that components such as engines, wings, and fuselage sections arrived at the main assembly line ready to integrate seamlessly. Conveyor belts, cranes, and specialized transport systems moved parts with precision timing, coordinated to fractions of a minute, while workers performed repetitive tasks with practiced skill, ensuring the production rhythm remained uninterrupted. Every rivet, bolt, and panel was installed with the dual purpose of speed and durability, creating aircraft capable of withstanding the rigors of combat even as they rolled off the line at unprecedented intervals. The human element was equally remarkable. Workers, including men and women, many of whom had never previously built an aircraft, were trained to perform highly specialized tasks with flawless timing. Teams were drilled not just in individual skills but in coordination, understanding how each action contributed to the larger assembly process. This collective mastery transformed the factory into a synchronized organism where thousands of individuals acted as extensions of the same system, moving, inspecting, and adjusting in unison. Supervisors monitored progress in real time, anticipating disruptions and intervening instantly to prevent delays, while engineers continuously refined workflows to further enhance efficiency. German intelligence, despite rigorous surveillance, could scarcely believe the scale and speed of production. Reports sent back to Berlin estimated that each bomber would take weeks to complete, factoring in the complexity of 1.5 million parts. Yet the reality unfolding in Michigan was far beyond their comprehension. The assembly line achieved the impossible, completing a fully operational heavy bomber every 63 minutes. The system's brilliance lay not only in its speed, but in the quality and reliability of the aircraft, each meticulously inspected and tested to ensure it was combat-ready. Pilots who later flew these bombers reported machines of remarkable consistency and resilience, a testament to the industrial mastery driving their production. The factory's logistical precision extended beyond assembly. Thousands of raw materials, from aluminum panels to intricate avionics components, had to arrive at the right place at the right time. Supply chains were tightly coordinated, with inventory systems tracking every part and contingency plans in place to prevent shortages. Cranes, trucks, and conveyor systems moved materials seamlessly, ensuring that production continued uninterrupted even under the immense pressure of wartime demand. The integration of logistics, assembly, and quality control created a self-sustaining ecosystem capable of delivering output at a pace previously thought impossible. Innovation was not limited to the physical assembly. It extended to problem-solving and process optimization. Workers suggested improvements, engineers implemented new techniques, and management continuously sought ways to refine every step of production. Small innovations compounded across the vast number of tasks, leading to significant increases in efficiency. The factory became a living laboratory of industrial engineering, where human skill, machine precision, and innovative thinking converged to achieve feats that confounded observers and astonished the world. Even the culture of the factory played a vital role in sustaining such output. Workers understood that every bomber represented a direct contribution to the war effort, instilling a profound sense of purpose and pride. This morale, combined with discipline and rigorous training, ensured that the production tempo could be maintained without compromise. Each individual became acutely aware of the larger mission, knowing that the synchronized efforts of thousands created a machine capable of dominating the skies and reshaping the course of the war. As dusk fell across the sprawling factory, dozens of bombers had already rolled off the line, each completed with precision, speed, and reliability. German spies, monitoring from afar, remained baffled, incapable of understanding the scale of this industrial marvel. Within Ford's plant, the hum of machinery continued, unwavering, each 63-minute interval bringing forth another bomber ready for the skies. The relentless rhythm, the synchronization of human and machine, and the audacious vision of industrial mastery were about to rewrite the rules of warfare forever. And as the next bomber began to take shape on the line, one fact became undeniable. The Allies had unleashed a force so precise, so fast and so unyielding that no conventional calculation could match it, and the world would soon witness the full scale of Ford's astonishing achievement. By the 5th week of continuous operations, the sheer scale of production had reached levels that seemed inconceivable to the outside world. Ford's engineers had optimized every process to near perfection. Engines were pre-tested in dedicated sections, wing assemblies were integrated with precision jigs, and fuselage sections were pre-wired and aligned to exacting tolerances before reaching the main assembly line. Conveyor systems moved each component with clockwork timing, while teams of workers, moving in near-perfect unison, performed thousands of highly technical tasks with minimal error. The factory had become a living organism, its human and mechanical elements perfectly synchronized to produce a 1.5 million-part bomber every 63 minutes, without compromise in quality or durability. Quality. Control systems were unparalleled. Each subassembly underwent multiple inspections. Rivets and bolts were checked repeatedly, electrical systems were tested for continuity, and engines were trial run before installation. Any deviation from specification triggered immediate corrective action, ensuring that every aircraft leaving the line was combat ready. Pilots flying these bombers would later report machines of extraordinary reliability, often exceeding expectations in terms of performance and resilience under combat conditions. This combination of speed and quality was unprecedented, confounding German intelligence and cementing the factory's reputation as the pinnacle of wartime industrial achievement. The human workforce remained central to this success. Men and women from diverse backgrounds were trained intensively, each understanding the critical nature of their role in the production chain. Teams collaborated closely, not only performing assigned tasks, but also anticipating the needs of subsequent stages, maintaining continuity and rhythm across the assembly line. Workers developed muscle memory and coordinated timing to such a degree that their movements became almost automatic, allowing the pace of production to remain steady and uninterrupted. Morale was high, fueled by the awareness that each completed bomber was a tangible contribution to the war effort, a flying testament to human ingenuity and industrial discipline. German spies, despite careful observation and repeated reports, could scarcely comprehend the reality of Ford's operation. While analysts in Berlin predicted weeks of construction per bomber, the factory defied expectation, producing a complete combat-ready heavy bomber every hour. The magnitude of this feat disrupted German calculations, forcing their strategists to acknowledge a new reality. American industrial might could deliver aircraft at a pace and scale previously thought impossible. The shock to the Luftwaffe was profound. The relentless output from Michigan translated directly into overwhelming aerial power in theaters across Europe and the Pacific. The factory's success was also due to innovations in logistics and material management. Thousands of parts, from aluminum sheets and rivets to advanced avionics, were delivered precisely when needed, coordinated through an intricate network of conveyors, cranes, and supply routes. Redundancies ensured that any disruption in supply would not halt production. Engineers continuously refined the flow of materials, optimizing routes and inventory systems to support uninterrupted assembly. The integration of logistics, assembly, and quality control created a seamless production ecosystem capable of maintaining the 63-minute cycle indefinitely, day after day. Even as production reached unprecedented heights, innovation continued to drive improvements. Engineers devised modular assembly methods, allowing multiple aircraft to progress in parallel without interference. Workers suggested enhancements, implemented new techniques, and refined workflows, creating a culture of continuous improvement that compounded across thousands of tasks. The combination of human ingenuity, machine precision, and organizational excellence created a system that was not only fast but adaptive, capable of meeting ever-increasing demands without sacrificing quality or reliability. As night fell across the sprawling Michigan plant, the hum of machinery persisted, unbroken and unstoppable. Another bomber would emerge in 63 minutes, followed by another, each a marvel of engineering and human coordination. German spies, unable to reconcile the speed and scale of production with their expectations, were left bewildered, forced to report back that American industrial capacity had achieved the impossible. Within the factory, thousands of workers and engineers understood that they were part of something historic, a transformation of the very nature of war, proving that ingenuity, discipline, and audacity could produce miracles. And as the next aircraft rolled forward on the assembly line, the world outside began to realize a sobering truth. The age of industrial warfare had been forever changed, and Ford's relentless assembly line had become a weapon more decisive than any in the sky. The Luftwaffe thought they understood American industry, yet what they saw unfolding in Michigan would shatter every expectation. German spies, hidden behind closed doors, their reports bound for Berlin, were utterly astonished. One bomber, composed of 1.5 million parts, was emerging from Ford's assembly line every 63 minutes, fully operational, ready to dominate the skies. They had expected slow, cumbersome production, bottlenecks, and delays. Instead, they witnessed a level of efficiency and scale that seemed impossible, a mechanical symphony orchestrated by human ingenuity and industrial audacity. Every second, every rivet, every engine installation moved in perfect harmony, a coordinated feat that defied conventional logic. The spies could hardly believe their eyes. America had weaponized its factories, turning mass production into a decisive instrument of war. The marvel of this operation lay not only in speed, but in secrecy. Ford's engineers and managers had designed processes that maximized output while minimizing exposure. Each subassembly, from fuselage sections to electrical wiring harnesses, was prepped in isolated sections of the plant, converging only when ready. Conveyor systems and cranes moved components with clockwork precision, while workers performed highly specialized tasks, each knowing exactly when and how to execute their role. The spies observed these movements with disbelief, recognizing that such synchronization required meticulous planning, rigorous discipline, and a scale of coordination previously unseen in wartime production. The integration of human skill and mechanical innovation was breathtaking. Workers moved with practiced efficiency, rivets flying, panels aligning, engines mounting as if guided by an invisible conductor. Supervisors and engineers monitored every station, instantly addressing any deviations to maintain the unbroken rhythm of the line. German intelligence noted that these operations could not be replicated without a vast workforce, extraordinary organization, and an almost obsessive focus on precision. Even the smallest delays were absorbed by a system designed to anticipate contingencies and maintain flow, ensuring that each bomber would reach completion in the remarkable 63-minute interval. German spies were particularly stunned by the quality of the aircraft produced at such speed. Each bomber underwent rigorous inspection at multiple stages of assembly. Rivets and fasteners were double-checked, engines tested under simulated conditions, and avionics calibrated with extreme precision. What seemed impossible to Berlin's intelligence was, in fact, a reality. Rapid production had not compromised reliability. Pilots later attested to the robustness and consistency of these aircraft, a testament to the engineers' unwavering dedication to both speed and quality. This combination of scale, precision, and excellence left German strategists scrambling to understand how such an operation could exist, let alone sustain itself day after day. The scale of coordination extended to logistics and supply chains, where thousands of components had to arrive at precisely the right time and location. Raw materials were delivered in exact sequences, cranes and trucks moved assemblies efficiently, and inventories were continuously monitored to prevent delays. Ford's operation functioned like a well-oiled machine, with every cog, human and mechanical, operating in perfect harmony. German intelligence had assumed bottlenecks and shortages would slow output. Yet the factory's integrated processes and redundancies ensured uninterrupted production, reinforcing the impossibility of what the spies were witnessing. Innovation was everywhere. Engineers devised modular subassemblies, allowing multiple aircraft to progress in parallel without interference. Workers contributed ideas that improved efficiency, adjusted workflows, and minimized errors. Even minor innovations, repeated across thousands of tasks, compounded to produce dramatic gains in speed and consistency. German spies could only report back a growing sense of incredulity, knowing that their estimates were entirely inaccurate. This was a factory functioning not just at maximum efficiency, but at a level of ingenuity and synchronization beyond imagination. As the factory's lights glowed late into the night, bombers continued to roll forward, each one a mechanical marvel, a product of human ingenuity and industrial genius. German spies, observing from afar, could hardly believe that one facility could produce fully operational aircraft at such a staggering pace. Yet the assembly line moved inexorably forward, one bomber after another, each completing the impossible task in just 63 minutes. And in the shadows of Michigan, the secret of this industrial miracle was being honed, perfected, and weaponized, leaving the world and the enemy on the brink of disbelief as America's factories became instruments of unstoppable aerial dominance. As weeks passed, the full scope of Ford's assembly line marvel became undeniable. Every 63 minutes, a complete bomber rolled forward, its 1.5 million parts assembled with astonishing precision, a tangible demonstration of industrial ingenuity and unrelenting discipline. Engineers and supervisors had refined processes to perfection. Engines were pre-tested, fuselages pre-wired, and wings pre-riveted, ensuring that every component fit flawlessly. Conveyor belts, cranes, and sub-assembly systems moved parts with clockwork accuracy, while workers executed thousands of specialized tasks in flawless coordination. Any deviation from the process was instantly corrected, maintaining the unbroken rhythm of production and ensuring that quality never suffered despite the staggering speed. German spies, observing from afar, remained in a state of disbelief. Reports to Berlin described numbers and precision that defied logic, with each aircraft leaving the line faster than any analyst could have predicted. The spies had expected bottlenecks, delays, and human error, yet none of these impeded the factory's output. Instead, the facility achieved a perfect integration of human skill, mechanical innovation, and organizational genius. Each worker understood their role in the broader system, performing complex tasks while maintaining awareness of how their actions affected the next stage of production. The synergy between people and machines created a living organism capable of sustaining unprecedented output, producing fully operational bombers that were combat-ready the moment they left the assembly line. Quality control was unmatched. Each sub-assembly underwent multiple inspections. Rivets, bolts, and wiring were double-checked. Engines run under simulated conditions, and avionics tested for precise functionality. Pilots flying these aircraft would later attest to their remarkable reliability, often surpassing expectations in endurance, performance, and durability. German intelligence was forced to acknowledge that speed had not come at the expense of quality. The factory had redefined the possibilities of wartime production. The sheer audacity and innovation of the system, combined with meticulous attention to detail, left observers stunned and competitors scrambling to comprehend the methods behind such unprecedented efficiency. The logistics behind this operation were equally extraordinary. Thousands of components, from raw aluminum sheets to intricate avionics, had to arrive precisely on schedule. Trucks, cranes, and conveyors moved materials seamlessly, while inventory systems tracked parts in real time to prevent any disruption. Contingency plans ensured that even unforeseen delays would not halt production. The synchronized integration of logistics, assembly, and quality control created a self-sustaining production ecosystem capable of maintaining the 63-minute cycle indefinitely. This intricate orchestration of manpower, machinery, and planning turned Ford's factory into a war-winning weapon, a reality that German spies could barely grasp. Innovation continued even as the line achieved perfection. Modular subassemblies allowed multiple aircraft to progress simultaneously without interference, while engineers refined workflows and optimized every movement. Workers suggested minor improvements that, when multiplied across thousands of tasks daily, created dramatic increases in efficiency and reliability. The factory became a living laboratory of industrial mastery, where human ingenuity, mechanical precision, and organizational excellence converged to produce a pace of output that the world had never seen and the enemy could scarcely believe. Morale and purpose were central to sustaining this operation. Workers, both men and women, understood that each bomber represented a direct contribution to the war effort. Pride, discipline, and commitment ensured that the 63-minute production cycle could be maintained day after day without compromising quality. The culture of collaboration and continuous improvement permeated every station, every team, every movement along the assembly line. Each individual became aware that their efforts were part of a grander design, a vision where American industrial ingenuity could directly influence the outcome of the war. As dusk fell over Michigan, the factory continued its relentless rhythm, unbroken and unstoppable. Another bomber would emerge in 63 minutes, followed by another, each a masterpiece of engineering, precision, and human coordination. German spies, forced to report the staggering reality to Berlin, remained bewildered, unable to reconcile their expectations with the facts on the ground. The relentless pace, meticulous planning, and extraordinary innovation of Ford's assembly line had redefined warfare itself, demonstrating that industrial genius could be as decisive as any weapon in the sky. And as the next bomber began its journey down the line, one undeniable truth became clear. The world would never again underestimate the power of American industry. And the secret that stunned German intelligence had just begun to reshape the course of the war.